A warm welcome from the 55th St. Gallen Symposium that takes place right here on the HSG campus, and where people from all industries and generations and from over 150 countries come together to join the dialogue. We took this opportunity to go out and ask some of our alumni what makes the symposium so special. Yeah, it's an honor to have you here as one of the founders of the ISC and the symposium.
Yeah.
Why is it so important to have this cross-generational dialogue?
Well, we didn't start as a first-generation dialogue. We started to demonstrate for the world, really for the citizens of St. Gallen, that we, the students at St. Gallen, had the willingness and the skills to have a dialogue with the establishment, as we called it in the state. We didn't talk about the generations, we talked about the establishment. Because the leftist students at other universities were demonstrating against anything in establishment. And we said, no, we want to have a dialogue with the establishment. And that's what we did here in 1970 for the first time.
For me, it's always to meet people, to have good discussions. I think that is for me the major point. And you find always people that you didn't know before, and you have a good discussion with those people.
Majority of politicians are actually from the old generation, and they take decisions which are favorable for their generation. But I think it's really important that the young generation has a platform where they can discuss and bring up their opinions and perspectives.
I think dialogue is important because you get to appreciate the other person's perspective. And age is a very determining factor in how you see life, how you see the world, how you see the future. So for me as an older person, it's very helpful to be challenged. And I hope that despite the fact that it's not very popular to be critical within your generation, I hope I can still challenge them.
For St. Gallen, it's a great opportunity to be the host city of such a conference. Can have here many guests from all around the world. It's very nice to host them and to be part of this dialogue.
And why do you think is it important that such a conference is organized by students?
Oh, I think that's probably most important to differentiate in the market of conferences around the world. I think I experience or attend so many conferences, but none of them is anything similar to St. Gallen. And this is not because of the content, it's because of the students organizing it, the ability to talk to students. When you're in a car and have a student driver, you spend 45 minutes quality time with them and can discuss intensively. It's so unique, and I hope this can be held up.
For me, it always shows the potential of the students.
These are some of the incredible HSG alumni we had the chance to catch up today. And now back to you, Andreas. The stage is yours.
Thank you very much. I think that was a great introduction. We are here live from the symposium in St. Gallen. We have around 25 people here in the audience, mostly students who have been invited here to join us. And it's the inspiration by one of our alumni. Jonathan Jasper, who's running a VC in New York, said he's confronted daily with the speed of urgency in the industries, and we should take Jacomo here to St. Gallen and have this session here. So that's how it all originated. I'm Andreas. I'm a professional board member and entrepreneur. I'm not a journalist. I'm a businessman leading this discussion, and that's how we handle as well. It will be not just a tech talk. It will be a stress test, because we are going to see two totally different companies. One hand, a 125-year-old legacy company who is being challenged as well by industrial AI, physical AI company PhysicsX. So with that, on my left, we have Stephan Wartmann. Thank you for joining today. Stephan is the CEO of the BRUGG Group, a Swiss conglomerate, more than 2,000 employees, close to 700 million Swiss francs in revenues. And if you go to Burj Khalifa, you see his products. If you, as you just shared, if you go to the Formula 1 race in Las Vegas, you have 300 of your people taking care of the safety nets in the Formula 1 race. So thank you for joining, Stephan. We have Jacomo, London-based, deep tech entrepreneur in the space of physical AI, right? And the CEO of PhysicsX. By now, already a unicorn, or close to it, right? You can share more afterwards. And he's using physical AI to rip up the engineering rulebook of many of our companies in the legacy system. We'll have 2 short polls for all the audience online, which we'll share here as well. We'd like to get your opinion as well, and we weave it into the conversation. We had many questions in advance already, which we try to cover here as well. And as the rule demands, the tradition, the 2 speakers will nominate the next speakers at the end of this session as well. All right. So with that, we start. And I think it's we're talking about AI versus the old industry at this stage. We'd like to show a short video of BRUGG, one of your divisions, and we'll take 1 minute, but I'd like you to make some comments about it so everyone understands a bit what you're doing in your business also. Should work.
Okay, BRUGG is about safety, is about security against natural hazards. And here it's about protecting people and infrastructure. There's no excuse. So crash testing, one-to-one testing, development step. Of course, we do a lot of numerical modeling, but what is even more important is the field tests, be it with rolling rocks, be it in the installation sites, but also certification tests according to international standards. We also do cabriolet, as you can see here, a comparison test to see how much energy is coming down by such rocks. We also do slope stabilization systems, debris flow barriers, as you can see here, and also there field testing is important. Here a shallow landslide test conducted in Japan, actually. Mining underground and open pit safety security is also here a very important aspect. And then there is some side business, also a little bit reflecting the natural hazards for, as you said, Formula One. We're also impact and intrusion. And at the moment, we're developing drone nets or have been partly already installed to have answers. It's about safety, it's about security and securing infrastructure and people.
Thank you for the introduction, Stephan. If you had to rebuild BRUGG Group right now with AI totally at the core of everything, would your business look different today?
I would say probably the main product, the main service would look rather similar, but we would be much more smoother and the development to come where we are today would be much faster. Let's take these field tests. I believe with AI tools, I mentioned numerical modeling that is supporting that, but with AI tools, I think we could accelerate the development steps. We could avoid 50% or even more of these field tests by just doing it differently. And on the service side, I believe that coming from the analysis to engineering design out in the natural, in the nature, every project is different. You have to do the stakeout, the geography, the threats, if we stay with BRUGG, and this to interact it closely with the production, the installation, the logistics. There is so much room for improvement if all the data flows together. And then also on the life cycle, so after sales services, we are targeting a sleepless package. Finally, somewhere with instrumentation, alarming in there, with different things we measure, data collected, but also connected with space. Projects are here, but not fully ongoing and interconnected. And I believe that having all the data and the products together from the very start, it would be much, much smoother, everything we do, more or less.
Thank you. Coming to Giacomo, right? And trying to define AI native engineering, right? Can you help us to explain your business for non-tech executives in the audience?
Sure.
In a simple way.
So I'll try. I mean, so what we are setting out to do is to change how engineering, manufacturing, and production is done in a number of different industries. So a lot of it oriented around advanced engineering, precision manufacturing, complex production. So, when we think about different industrial verticals, it's really sectors like aerospace and defense, maritime. So think of ship hull building, for example. Think of semiconductors and really, a lot of the supply chain, whether it's what happens in the fab, but also, we're working on the next generation AI data centers. So really these large AI GPU gigafactories, together with Siemens, together with NVIDIA. On the semiconductor equipment manufacturing side, it's companies like Applied Materials, right? So that are making the equipment that is used in processes to take a silicon wafer to ultimately have a chip that's made. We're working in automotive with the OEMs, and on they're on some of the more complex engineering that they're doing, and also on things touching the control. So control, for example, of cooling in the battery unit. And last of all, we're working in mining materials and energy. So a lot of the things that we do are more oriented towards processing intensive commodities. So think of copper and lithium, think of aluminium and steel, think of steel, or scandium alloy production. So, the common denominator is that there's complex physics simulation or chemistry simulation that's in the loop. As you were saying, that a lot of, the work that you're doing, any testing runs through one of two things. It's either running through real world tests, so physical tests, the field tests that you were describing, or it involves numerical simulation. So numerical simulation involves solving equations of physics by finite differences on grids and meshes. It's very compute intensive workloads. They take a lot of time, and ultimately it's the complexity of those workloads. It's how much time things take that are a bottleneck to automation and optimization, and ultimately to engineering productivity. And so what we're building is a software stack that allows you to do those simulations with AI models, right? So AI models that do this on inference, and the big benefits are, one, these deep learning models are between 10,000 and 1 million times faster than a numerical simulation equivalent. It's also the fact that, building numerical simulation that is a very, very good representation of what happens in the real world is hard to do in complex situations. It's why so much of aerospace involves physical testing, right? So, a company like GE Aerospace that makes a jet engine will, do a lot of the testing, not just virtually, but in a wind tunnel, right? You described the field test that you run as well. Semiconductors is very wet lab driven. There's a lot of, physical testing and iteration that happens. And the nice thing about deep learning models is that we can train, yes, on a corpus of data, which is a lot of it is numerical simulation, but we can also train directly on experimental data, on data coming from a wind tunnel, from a wet lab, from a dyno, from a field test, from a jet engine that's on a plane. All of these things mean that we can get to virtual representations of the performance of the physics or chemistry that's in play, that even supersedes the accuracy of the numerical simulation, but crucially is a whole lot faster in the way that I described before. So ultimately that's what we're building.
Thank you. We had two questions from the audience ahead of registration. If you look at your customers, right, is it a matter of urgency that they want to really implement and they believe in it, that's the right way? Or is it rather a defensive strategy because the old models are just disappearing and they have no other choice?
I think in a lot of the industries in which we play, it's a recognition that the complexity of the products that they're trying to bring to market, the things that they're trying to do, have outstripped the tools that they use today, right? So if you think about making semiconductor manufacturing equipment at the 2 nanometer scale, that is incredibly complex. And I mentioned before that numerical simulation models just are not accurate enough to really, bootstrap a lot of the design and engineering and get to something that can be deployed in a fab. And so they do as much of the virtual, as a lot of this runs through wet lab experimentation. And the moment things run through real world testing, there's, things take more time. Now, what's happening in semiconductors is that, really driven by one company, NVIDIA, the whole supply chain has moved from sort of a 3-year product development lifecycle to 2-year, and now is being reoriented to 1 year. And that is forcing, the semi-cap players, everything that's happening on, advanced packaging, the whole supply chain to invest a whole lot more in R&D to rethink how they do things. And that means, trying to break through barriers that they have right now. And a lot of that runs through numerical simulation. So we are trying to help them get to productivity or performance that they can't get at on today's software. And, in other sectors, the dynamic might be a little bit different, right? So when we look at automotive, a lot of it is motivated by, Chinese competition, right? Like everyone realizes, the large European OEMs or Western OEMs realize that they have to dramatically, shrink or shorten their product development life cycles. They have to be able to recover cycle time. They have to be able to put out a new vehicle in 2.5 years versus 5. In other sectors, it's really motivated by, trying to, bend the cost curve of the capex required to build a new copper concentrator, or trying to, improve the OpEx, the operational efficiencies tied to a large data center. So the different sectors will have their own imperative. But I think the meta point here is that there is a general recognition that, AI should be bringing and can possibly bring a new S-curve in productivity, opens up a new set of opportunities with respect to doing the work that these companies are doing, whether it's in engineering, whether it's in manufacturing, whether it's in production. And so we're riding a little bit that tailwind. Yeah.
We asked the audience for a poll. What are the biggest barriers in AI adoption? And I guess we'll get the result quite soon. You as an AI company, has AI ever failed you?
Absolutely. Right. So, and I would say that, look, when we set up the company, I'll be perfectly candid that PhysicsX was set up really as a vehicle for experimentation more than anything else, yep. Right? It was unclear that the methods that we're leaning on, like trying to build deep learning models that are, that can, be very good, proxies for the numerical simulation, but still meeting, the fidelity requirements, the accurate and precision requirements of engineering applications that are of a complexity that numerical simulation, let's say, or physical testing is a real bottleneck. We just didn't know, like that's an empirical point. And so, we started out by experimenting in the first place in aerospace, simpler applications, intercoolers, heat exchangers. There are no moving parts. It's all steady state physics. Before we started getting into FEA and multi-material FEA, before we started getting into turbo machinery. So now you have really moving parts. And so we built incrementally into new physics, but on the way, there are plenty of things that we tried to do that didn't work. that didn't meet the fidelity required of that specific application. Even today, like there is certain chemistry, for example, that we don't know how to build models for that are, again, going to meet the requirements of the engineering or manufacturing applications where those things are relevant.
I think it's going into the direction of the results we see here, legacy systems data being the biggest challenge ahead of talent shortage, 25%. But I guess as a highly successful deep tech, talent shouldn't be the main issue for you. But we'll come back to talent later on what kind of skills you need, what kind of engineers you need. You have seen Stephan's group, right? BRUGG Group. How would you pitch your company to him as a CEO to make him implementing your products?
Well, Stephan, I would start by, and we often find ourselves, like say, pitching to engineers. And the one thing that's true of engineers in many different sectors is that, engineers are kind of bound by this ethic of continuous improvement. Like they always believe that there is a better way. Engineers are typically, not proud or comfortable that they've found somehow the very best way of doing something. And so we very much will, start off by describing some of the technology that we're building. What are the engineers are very, interested in methods and understanding, what's under the hood. And so I think we would start by, talking a little bit about, the models that we're building. These are the levels of fidelity that we're able to get at. And this is what it means in the way of speed like the speed that it buys you. This is what it means with respect to, dramatically simplifying the FEA simulations that you run right now, being able to do right first time physical field tests so that you're not having to fail a test and rework. This is the same thing that we meet in working with automotive OEMs, where they do a whole lot of crash testing. And so, I think we would try to show you adjacent examples where we're doing very complex multi-material FEA, finite element analysis. So we're looking at, things touching with how something will deform or change shape and react under loads and forces. So, understand structural stress, fatigue models. And then after that, I think what I'd love to anchor, I wouldn't want you to take at face value that this is going to solve all your problems. I would want to say, what is a very high value problem on which we could demonstrate that the technology works and meets the complexity of the engineering and the, manufacturing of the products that you're making. And then, that is an initial pilot, and hopefully we can meet whatever success criteria we set out, together and can agree on. And, on the back of that, I would hope that you find religion about, the kind of platform and software that we're building.
Sounds to me a little bit like the Japanese method, Kaizen.
Yeah.
Just with another tool and other opportunities and much more speed. And there's probably the biggest value. The final goal is probably still the same. And the final field test will probably not have, will have to take place, because we just had last week a big customer event. They come from Australia, from Colombia, from Chile, from the United States, from Canada, or from Asia. They want to see a 2-second event. And it's the best marketing tool. Seeing means believing. Mm-hmm. But everything that comes before, I'm fully with you, should be with much more speed and much less field testing, because that's costly.
Yeah. No, and it's worth saying that it is also the case that in a lot of the places, the sectors in which we operate, there are regulatory requirements. So in aerospace, for example, there's FAA, which has to certify everything that an aircraft that is going to be manufactured. And so even the engineering tools themselves are certified. The whole process by which you do final validation before you go into production has to be certified. And so we certainly don't want to tell our customers that, look, the only way in which you can consume our technology and get the benefit of it is by, first going through a certification process. And so what we will, do with and aerospace is our largest sector, we will, we're talking about an engineering problem, we will, work with them to be able to use their technology to be able to search much larger spaces, to design something that is going to work better. But then instead of using, the numerical simulation tools, every step of the way in order to be able to get at that final design, we're using these very, very fast inference models to, search a larger design space, get to a better design, and then we do final validation on the numerical simulation on the certified tool chains, and then you go into production. Yeah.
To be brutally honest, Stephan, are you looking for cables which are 5% cheaper, or are you looking to change your organization and refine the job done by your engineers?
We are already 10% more expensive than everybody else. So the answer is given. It's the added service, it's the lifetime, it's the oldest service around, and especially also the supervision in the end. That's probably an order, eh?
Well, if it's your key customer, you should pick it up.
It was from Kyrgyzstan, actually.
No, it's his sales development team following up.
No, it's very important. It's not only about the products, it's about the service, the lifetime. We also build cables for elevators, but also for ski lifts, and urban transportation is a big thing at Fatser, which is another business unit. And there we don't run from 9 o'clock to 5 o'clock like a ski lift. It runs 24/7. And you have maybe 2 weekends where is a holiday where you can do any maintenance. Their quality, lifetime management and service is totally decisive. And there we have AI tools together with our sensoring systems installed and operating, and we do that actually for the client. So it's a recurring revenue model, actually. No, because this, you have a train or a tram or a subway, metro. They are not used to do skyways with cables. In Paris, we have installed middle of December an elongation of a metro line, 5 kilometers. With a cable car. It's like the one in London. That's also with our rope, by the way. And to do that underground, it takes 5 years planning at least. It takes 10 years building. It takes only half a year planning when you do it the way it was done, and it's installed in another half a year. But then operating is something completely different for them. So they want to have as much service as possible to have the continuous flow.
Well, I like to hear your reply. Your sales guy just called. In 10 years, PhysicsX powered BRUGG Group, will they have 500 engineers or 50 AI prompters in the organization?
That's a great question. Look, if I think we're in a world increasingly where we need, a lot of the companies that we're working with, and that's BRUGG as well. If you drive down the marginal cost of product development, you will be able to have a broader product portfolio. You'll be able to do more. You'll be able to serve your customers at lower cost. Like that will allow you to eat more market share, to provide more offerings. I'll call out, one of our customers, Applied Materials. There are 2 out of the last 7 or 8 quarters where they have specifically called out a shortage of engineers to do all the things that they're trying to do on the product development side. And that's not unique. We have a number of customers in aerospace, and beyond, where they can find all the engineers that they need to have. And this is not just engineers. There are bottlenecks in production, manufacturing operators, system engineers. Even in the energy and material space, like there's a shortage of, let's say, process engineers, and these problems are not going to go away with an aging workforce on the one hand, and with not enough STEM graduates. Certainly that's a problem here in Europe, but it's also a problem in the US at a point in time where it's trying to reshore more and more manufacturing. And so I think engineers, STEM graduates writ large, but engineers specifically are in high demand. It's not a question of no engineers. I think those, unless you're doing very low complexity things. I mean, and again, that is making it more possible for a broader set of organizations to be able to, touch hardware, to be able to make things themselves, to be able to design things. Just think at one level, if people are familiar with CAD, right? So computer-aided design, this is software that allows you to manipulate like a 3D geometry, right? So there are many more people who can operate CAD software than people who can operate, simulation software, numerical simulation software. So, it's roughly, there are 10 times as many people who operate CAD and who work in CAD as people who operate simulation. Why? Because that numerical simulation software is highly complex. It runs through people who have deep understanding of the sort of the physics phenomena in play, whether that's finite element analysis or computational fluid dynamics simulation, whatever the simulation might be. AI is providing an opportunity to really democratize these tools. There's a lot that's happening in CAD, and some of you may look up that just last week Anthropic announced this Claude extension for CAD. So certainly AI is going to change all of these disciplines that are relevant to physical engineering and manufacturing, but also including simulation. And so I think some organizations that could not have hired simulation engineers or even maybe CAD designers are going to be in a position to be able to touch designing and manufacturing. But for people on the higher end of complexity, they need all the engineers that they can get. But it is a question of productivity.
I would give you a brutal answer. There will be probably the same engineers with us in the future, I hope, because they have so much knowledge. Even if we have the best specialists from the market, we are so much in the niche that it takes 2-3 years to fully understand what we do. But we will have two kinds of employees in 5 or 10 years. The ones that have all the know-how and use intensively all the tools that are available, or the best possible tools are available, and the ones that are not with us anymore. That's a brutal answer and maybe a little bit too generalized, but it will go in that direction. We should, the ones that close the eyes from the new possibilities, they limit themselves so dramatically that they outplacement then themselves one day.
So a question of the culture you're creating in your company as well then, right?
Of course, we have to do it step by step. And I'm not expecting everybody to turn the head within a minute. So that's the horizon in 3 to 5 years, or maybe even a little bit more.
Yeah.
But we need to speed up, and we should have started yesterday.
I'd like to do a short question round, rapid fire questions here to get the personal side as well to the audience of our two speakers. One word, please. Both cannot be the answer. Leadership, trust, or control?
Trust. Trust.
One match. We're not counting matches anyways. Strategy, evolution or revolution?
That's a good question. I think evolution, it's iteration.
I would say the same, yeah.
Okay.
Sorry, it's boring.
Now we start here.
Okay.
Philosophy, fail fast or never fail?
Fail fast.
Absolutely the same.
Okay, so we're still quite close. Now we get to AI, and we start here.
Yeah,
again.
okay.
Co-pilot or put on autopilot?
We have rolled out Copilot widely and early. It's not the best, but it's really fitting into what we do on a daily basis.
Copilot as well. Okay.
Look, I think it's Copilot, but not being afraid of autopilot. Like and let me just explain that. I realize it's supposed to be one word answer. So
I love this. I'm interested.
But what people were conceiving of a few years ago as Copilot, just think of code and how the discipline of software engineering has changed. It used to be that you'd have tools like, GitHub Copilot, which were really more than anything else glorified autocomplete tools. But they have gotten a whole lot better, much, much better. And now we can really, they are providing huge productivity, contributing most of the lines of code, even for very complex, code bases. We're also getting to a place where these agents are able to operate more and more autonomously, are able to complete a sequence of tasks, we're in a place where you can get to long run agents. At today's sort of frontier model performance, models like Opus 4.7, latest Codex models are able to operate at 95% reliability on tasks as long as about 4.5 hours or so. We're about a year out or 18 months out from a place where it's going to be a full working day. And so that dramatically changes how we have to think about using the tools. And in that world, it is much more command and control. There are some tasks that you're absolutely delegated, that you're running in autopilot mode. But by and large, there's still going to have to be work done. And a lot of that is going to be orchestrated by people. And there's going to be a Copilot paradigm for a lot of that.
Great. Fantastic explanation. Last question. Your business threat. Silicon Valley or China?
Oh, that's a great question.
One answer. This time, sorry, I give you one.
Silicon Valley, and let me just explain it. I think in our world, there's just a reality that there's a geopolitics in play. We are touching industrials. We're touching companies in the very sensitive industries, or these are recognized, whether in the US or in Europe, as critical industries where people are really thinking about sovereignty or really, having, industrial champions tied to you as opposed to just consuming the technology. And so certainly for us, one of the things that's happened a little bit with China is that there is a balkanization of supply chains. And so when people think about developing AI for these sectors, it's not clear that, let's say, Chinese models, Chinese technology can deploy into a European or a US aerospace prime or into a company like ASML or Applied Materials.
Thank you.
I would say China.
Purely because they produce your competitive products at this stage as well.
You said one word.
That's good. Thank you very much.
No, but it's the combination. We always have hardware that goes together with service and so forth. Yeah. And when I look at the energy and material prices, we can, even in our own factories in China, which we can achieve, then there is so much advantage today, but even more tomorrow. No.
We'll cover now a few points on geopolitics, right?
We disagreed on something at the very end. Fantastic.
Doesn't matter. That's good.
Yeah, so at least one match. I wanted to come back to the summary at the end, but that's right. We had a poll with the audience as well on whether Europe can win the industrial AI or AI race against the US and China. We should see the results very soon, but we'd like to take the points from geopolitics on AI and industry as well, right? Stephan, do you think is Europe still relevant? Is Europe still competitive? Or are we slowly becoming irrelevant in this world?
I wouldn't say so. If we limit us to Europe, yes, then we're on a bad train. But if we are open to do integrated research together with the people from the United States and also together with people from China, for instance, from Asia, including India, which is having a great source, and take the very best from everywhere. And we, as having a global operation with factories in the United States, but also in China, we have our own people there, people we trust, people we build on, and we have local market. And that's where it makes the diverse combination. Take the best out of Europe and combine it, what can be found in the US, in India, or in China. It's not that easy, but it's really, if you achieve that on an organizational level. And there, Europeans must be much more humble than they used to be in the past, because the work ethics, the speed is so high. When I look at our employees in India, in China, in Asia, it's just another world. Yeah.
Well, we got the answers in. 37% believe we are too slow, and 58% go in the direction, as you're saying, we probably need to consolidate and learn across borders as well, right? Giacomo, you were very busy today. You already had 2 sessions, 2 panels today, right? And you were a vivid believer in the European opportunity as well to lead AI for the world, right? I would challenge that a little bit based on what I discussed today as well with different people. Thank you, Stephan. Speed adaptability in Europe is still, as Stephan has just mentioned, far behind. Do we really think that Europe can still win? Is it hope, or is it really your belief that this can be the center for your business?
So it also depends what we mean by winning, right? You know, when I think of Europe winning, I mean, I think of a few different dimensions. I think of, you know, creating economic opportunities for the people that live in Europe, and that means having, a labor force that is, sort of gainfully employed in the very best jobs in whatever sectors we're ultimately, talking about. And, that ultimately, I think, is not just a question of European companies employing Europeans. It's also a question of, other global companies, US companies, Chinese companies, Indian companies, locating themselves here, doing manufacturing in Europe because there's an end market, over here, locating R&D here because we got the very best, human capital and talent located here in Europe. So, and that is one important part of having a, dynamic and growing economy. So that's one. There's another dimension where, people will agonize over the fact that, we don't have a, $1 trillion, a European company with a market cap above $1 trillion. When is that going to happen? It's going to happen relatively soon. Maybe ASML might be the first one. But the short of it is that we are, Europe itself needs to think a lot of its companies have to be thinking about winning globally. All right, Stephan, this is a little bit the point that you made. Like you've got manufacturing and you've got headcount in a number of your operations are globalized because you're trying to sort of sell your products globally. Certainly Chinese companies are trying to win global market share. I think it's very important for Europe to be thinking about how do we set up the conditions to have more European companies compete globally, not just compete and win share or keep share within European borders. And I think on the part that I'm maybe more optimistic about is there are in a number of different verticals, and here we're talking more about, let's say, industrial verticals, where Europe has deep heritage, companies that are incredibly competitive, machines that have a large installed base, all of which I think, provides it with, very, very good distribution in ways that allow it to continue to, rethink how they, do engineering, do manufacturing to compete at the very, very top tier and continue to win market share globally. So I think, and that's not just true in industrials, I would even throw in, let's say, pharma as part of that. The part that I'm a little bit more pessimistic about is, how do you create the conditions to have a stronger ecosystems here in Europe? Like, the cost of, when we talk about manufacturing, for a lot of manufacturing segments, about 20% of the cost of manufacturing will be tied to the cost of energy. So what does it mean? It means that there is, even European companies will be thinking about moving manufacturing away from the European continent. But we're also in a world where manufacturing and increasingly R&D are more and more co-located. And so manufacturing going away is actually sucking engineering away. So I think there have to be policies in place to try to bring back and reshore, and strengthen manufacturing happening here in Europe. I think that's going to attract more R&D, but I also think it requires, a ultimately lower cost of capital, to building up operations here in Europe. And some of that has to do with, labor laws. And, if it is very difficult, if it is easier for me to hire an engineer, let's say in the state of Ohio or in South Carolina, and I'm really thinking about some R&D experiment, and now, doing the very same thing in Germany means that I'm maybe taking on this long run liability because I can't get rid of that engineer if that experiment, if that plant isn't that successful, then I will always choose the US. I will always choose some other place besides Europe. And that to me is a, I think people have dwelled on and been, people have pointed out this problem around labor liberalization laws for some time. That is the part that I'm most pessimistic about.
Would you agree with that, Stephan?
Yeah, talking about global products, I believe it's dangerous to have a one size or one type fits all. We are currently developing or developed specific China-specific products, China-specific solutions for China, because I always say when we are in China against the Chinese competitors successful, then we can conquer the whole world. And out with that know-how, we are also successful outside China, not covering the whole world, but allowing what can be done there, also with the speed, but maybe not with all the requirements you have in other countries. So stay flexible. Also maybe have a global thinking, global development, but a local finish somehow. It's probably describing it.
So the dynamic that you're describing is one that I at least hear about from some of our customers in other sectors as well. When people, some of the automotive OEMs that we work with, they, and by OEMs we mean like the equipment manufacturers, the brands themselves, like that make the vehicles. They will talk about competing with Chinese products, but the way in which to do that is to locate more and more of their production and their supply chain in China, so that they are more cost competitive, so that they can iterate more quickly, so that they can sidestep, let's say, in some sense, even works council restrictions. Like that to me, I think is fine on an interim basis, but I would hope that things are able to, some of the constraints or some of the things that mean that we're in the situation that, that we're in right now, with Europe having just every company having to think about labor in terms of a higher fixed cost, that some of these things go away.
But it's also about know-how. Let's take GM, Hyundai, Volkswagen. They are developing their EVs not in Europe or not in Korea. It's now in China because there It's not about it's being close to the big OEMs there, but also to be around their subsystems. And from their subsystems, you can learn a lot of things. Information flow through, even if there is a Chinese wall or not, it goes through, and it's creating a cluster where you can only benefit from.
Yeah,
BMW, we heard this morning, is doing it differently. I'm not so sure whether this fits in the long run, because there's a big advantage in EV at the moment in China with many aspects.
Well, we brought BMW together with PhysicsX this morning already, so there will be some solutions there as well coming up. I'd probably like to take one more topic up before we open the floor for a question here from the room. Future after AI, right? I mean, it was not long ago we didn't really talk about AI. Now, agentic AI, quantum computing, etc., are coming up as well in many facets. These technologies, whatever it will be in the future, might make all our businesses obsolete. Who will be disrupted first? You or your customers?
Oh, it's I mean, that's a great question. Right now, for those who may not have been following since the beginning of February, there's something in the public markets called the SaaS apocalypse that's been taking place, and it's like the whole idea here is that these horizontal, these frontier AI models like Claude are eating all of software, right? So they're not just they're driving down the marginal cost of developing software and a tailwind to companies that are building software, but that they are these frontier models are obviating the need to have things like human capital management systems, so HR systems, or eating into the even big systems of record like ERP systems or CRM systems, so customer relationship management systems, so things like Salesforce and whatnot, or HubSpot. So there's a number of these companies, like a lot of I don't know exactly how many trillions of dollars in value has been wiped off the that segment of the equity markets, but it's well more than $1.5 trillion as of about a few weeks ago. It continues to be the case for us that we are not building models with a language backbone, right? So we are building models that are trained on mostly numerical simulation and experimental tests. There is no, most of these language models until about mid-24, about 60% of the data that went into frontier AI models was based on something called Common Crawl, but it's basically language, right? It's language and a corpus, an open source corpus of data of the internet that was crawled and put into a format where models could train on that. Now, when we talk about industrials, there is no such thing as Common Crawl, and maybe that means that we are safe to a degree, right? To a degree, but at the same time, these frontier models continue to get better, and we are following scaling laws. We are continuing to raise more capital. Our customers are, we're collaborating with them in order to be able to help them follow scaling laws themselves within their engineering domains and train ever larger models. This is precisely why we're very focused only on working with very large, enterprise companies as opposed to smaller companies. It's precisely because of the scaling law point. But it remains to be seen. It's very much an open question whether these frontier AI companies that have we're going to see 2 IPOs later on this year, OpenAI and Anthropic, at market caps of over $1 trillion. Those balance sheets allow them to continue to follow scaling laws, and I think in a lot of other domains, to go into biology and life sciences, maybe to go into the industrial space. So, I don't think we can be confident and to say, oh, this trend does not apply to us.
Mm-hmm.
Yeah.
And for you, Stephan, 5 years from now, what would you regret not doing today?
I would say probably that we have not started yesterday with AI implementation. We have been applying in certain areas already quite a long time, like 15 years or so. But this is more very simple AI, but more in the general view, and to motivate the people to come along.
Yep.
And to become the BRUGG employee using AI on a daily basis to make him or her much better, faster, and as a better brick in the entire building. So, yeah.
Very much in line with what you said before as well,
Yeah,
right?
yeah.
I like to open the floor here at the audience in St. Gallen. Is there a question here from the audience you like to raise?
And if there aren't, we're going to pick on you. So
That's right. Otherwise, I like to conclude this session. Thank you so much for being here with us today. I think as tradition demands, I like you to suggest as well the next speaker in this series, the next nominee. Maybe Stephan, who do you suggest we should take on?
Well, we talked a lot about AI, computing, and all these data, they must go through a data center somehow. And a company very nearby St. Gallen in Herisau, Huber & Suhner, has a very sophisticated and future-driven CEO. It's Urs Riffel, and I believe that he would be a very interesting person to be on this podium here.
Thank you. That's a great nomination.
And I would nominate Roland Busch, who's the CEO of Siemens. I think we're a Siemens portfolio company. A lot of the things that we're doing are complementary to them. They're also a customer of ours. We're working with them, as I mentioned, on data centers. Siemens is an organization that is very much at the vanguard of everything happening around industrial AI. They're also a large manufacturer themselves. They operate more than 175 manufacturing plants globally, a number of which are in China as well. And so I think, he would bring an incredibly interesting perspective.
Thank you so much. A great nomination as well. And maybe we'll do a combi session at the end on this topic. Could be interesting. But I'd like to thank both of you for joining today. For me, as mentioned in the beginning, this is a tech talk, but at the same time a stress test. We try to build it a little bit like this, but surprisingly, there are many matches as well in the fire discussion, right? And I hope this business can continue in the future. But thanks for being here at the St. Gallen Symposium. I'd like to thank our audience here in the room and as well the audience online for joining today. You should have received already the next input. Actually, we have a session 1st of July with the CEO of Lidl, who is leading 400,000 people across the globe as well. And then afterwards, we'll come back to data centers and tech. So much appreciate. Thank you for joining today.
Thank you.
And
Thank you,
to all of
Thank
you,
Stephan.
a great evening.